In this video, I am going to explain worksheet questions of thermodynamics. So here also I have selected some important questions. We will discuss one by one. So first, in the reaction, H2O liquid changes to H2O gas at 0 degrees centigrade and 1 atmosphere. The internal energy change is given, that is H2O liquid changes to H2O solid at 0 degrees centigrade and 1 atmosphere. So given value is delta U. Internal energy change means delta U is given minus 41 kilojoules per mole. So from this we can calculate delta H, enthalpy change. Delta H equal to, we know, delta U plus delta Ng into RT. So delta Ng is change in number of moles of gaseous products and gaseous reactants. That is summation of sigma n of products which are gases minus summation of number of moles of products which are gases. Here gases are not present in given equilibrium. Liquid and solid is present. Therefore delta Ng is 0. Therefore delta H equal to delta U, which is given as minus 41 kilojoules per mole. So option A. So change in number of moles of gaseous products and gaseous reactants. Here reactants. So no gases are present in given equation. Therefore delta Ng equal to 0. Therefore delta H equal delta U. Next. So air bag contains the air which an expansion gives 5% increase in volume. The percentage change in pressure given gamma of air 1.4. Simple question only. So for adiabatic change, we can write PV power gamma equal to constant. PV power gamma equal to constant. So differentiating. So first P into gamma into V power gamma minus 1 into dV plus dP into V power gamma equal to 0. So from this P into gamma V power gamma minus 1 dV equal to minus dP V power gamma. So from this dP by P equal to gamma into dV by V, or we can write like this in terms of percentage, dP by P into 100 equal to minus gamma into dV by V into 100. Percentage change. So here given gamma value as 1.4, so minus 1.4. Next, increase in percentage, that means 5% increase in volume. Increase in volume is given, that is 5. Therefore, so minus 7%. So here minus indicates decrease. So therefore, percentage decrease in pressure equal to 7%. Therefore option C. So here minus indicates decrease. Next. A certain mass of gas was brought from state A to state B by following three different paths, namely 1, 2, 3 respectively. Which of the following relation is correct about work done? Here three processes are given from graph. Work done equal to area under the curve. Area under the curve represents amount of work done. Therefore, so 3 graph has more area. 3 graph. Therefore, work done is which is maximum for 3. W3. Next medium for 2. Next minimum for 1 is increasing order of work. So for graph 3 there is maximum area, therefore maximum work. For graph 1 minimum area, therefore minimum work. So work done is W1 less than W2 less than W3. Option B. Next. So which of the following is not an intensive property? So what is meant by intensive property? The thermodynamic property which is independent of amount. Intensive property means which is independent of amount. Not an intensive property means that should be dependent on mass. Here clearly entropy S is extensive property. That means which depends on mass. So entropy, internal energy, U, enthalpy, H, and free energy. Free energy means gives free energy. All these are extensive properties. I will write commonly. Extensive properties. So therefore option A, it is not intensive property. So extensive properties means the thermodynamic properties which depend on amount of substance. Next question. Find the equilibrium constant K. Equilibrium constant K of the reaction at 300 kelvins when standard free energy change is given. Take R value 8.33. So we know delta G naught equal to minus 2.303 RT log K, which is K equilibrium. Delta G naught is given minus 25 kilojoules. Kilo means 10 cube. Equal to minus 2.303 into R value 8.33 into temperature is given as 300 into log K equilibrium. So from this minus minus cancel, 2.303 log K equilibrium equal to 25 into 10 cube by 8.33 into 300. So which is equal to 10 value. So this value will be ln K equilibrium base E. This is base 10. Log means here base 10. Ln base E equal to 10. That implies K equilibrium equal to E power 10. So E power 10, C option. This is the equilibrium constant. So relation between standard change in free energy and equilibrium constant. Next, for which are the following systems the difference between delta H and delta U is not significant. So not significant means we know delta H equal to delta U plus delta Ng RT. So for solids and liquids, delta Ng will be equal to 0. Therefore, for solids and liquids, delta H equal to delta U. So therefore, for first option solids and fourth option liquids, delta H equal delta U. Therefore, option A. Next. For a chemical reaction, the standard change in free energy is minus 7.64 into 10 power 4 joules per mole. What is equilibrium constant? That means here we should find relation just. So delta G naught equal to minus 2.303 RT log K equilibrium, which is base 10. Here it is given minus 7.64 into 10 power 4 minus 2.303 RT log K equilibrium base 10. So therefore minus minus cancel. Log K equilibrium base 10 equal to 7.64 into 10 power 4 by 2.303 RT. So which is positive value. So positive value means K equilibrium must be greater than 1. R value positive and T value positive. So therefore equilibrium constant must be greater than 1. Option B. Next. The standard enthalpy of formation of the substances CO, CO2, N2O, N2O4 respectively are given. The enthalpy change in kilojoules of the following reaction N2O4 gas plus 3CO gas gives N2O gas plus 3CO2 gas. For this we must calculate change in enthalpy delta H. All are in kilojoules only. So delta H for the given reaction is delta H N2O plus delta H 3 into delta H CO2 minus of delta H N2O4 plus 3 into delta H CO. That means simply your formula is delta H of reaction equal to summation of delta H formations of products minus summation of delta H formations of reactants. This is the formula. Delta H of reaction in terms of change in enthalpy of formations. Formations of products minus formations of reactants. Here N2O, CO2 are products and N2O4, CO are reactants. So substitute the values. Delta H of reaction equal to delta H N2O value 81. So plus 3 into delta H CO2 value is given minus 393.8 minus 393 only. So minus delta H N2O4 value minus 10. So plus 3 into delta H CO value, that is also minus 10. So from this we'll get value minus 1058 kilojoules per mole. So minus 1058 answer. Your options are not given. Yes, answer is minus 1058 kilojoules per mole. Delta H of reaction in terms of formation of reactants and products. Next. Similar question. So given delta H reaction for CO2, not reaction here, it should be formation. Delta H formations of CO2, CO, H2, H2O are given respectively. Delta H of reaction we must calculate. So delta H of reaction will be equal to summation of delta H formations of products minus summation of delta H formations of reactants. That is, so here CO2, H2 are reactants, CO and H2O are products. So from this we can write delta H CO plus delta H H2O minus delta H CO2 plus delta H H2. This is the formula. So substitute the values minus 110.5 minus 241.8. Next minus of delta H of CO2 minus 393.5. Delta H formation of H2 is 0 because H2 is standard form. Therefore, from this we'll get value 41.2 kilojoules per mole. So option D. This model is very, very important. Delta H formations of products minus delta H formations of reactants. Just substitute the values. So formation of H2 can be taken as 0 because that is standard state of hydrogen. Next. Given N2 plus 3H2 gives 2NH3. Delta H of reaction is given minus 92 kilojoules. So from this standard molar enthalpy of formation we should calculate. So here for 2 moles, of NH3, delta H equal to minus 92 kilojoules. Therefore, delta H of formation of NH3 is equal to minus 92 by 2. So which is minus 46 kilojoules. So delta H formation means for 1 mole we must calculate. For 2 moles value is minus 92 for 1 mole. So 1 mole of NH3. So heat of formation means the amount of heat absorbed or released when 1 mole of compound is formed. But here 2 moles minus 92. Therefore for 1 mole minus 92 by 2 minus 46. So option D. Next. So this is also important question. Calculate delta H in kilojoules per mole of the reaction C2H5OH plus 7 by 2 O2 gives 2 CO2 plus 3 H2O. So your values are given. Delta H formations. Delta H of reaction equal to summation of delta H formations of products minus summation of delta H formations of reactants. So here products are 2 into delta H formation of CO2 plus 3 into delta H formation of H2O minus of delta H formation of C2H5OH plus delta H 7 by 2 into delta H formation of O2. Here O2 in brackets, ethyl alcohol in brackets. Check here values. So 2 into delta H formation of CO2 is given minus 400 plus 3 into delta H formation of H2O minus 290 minus delta H formation of ethyl alcohol 280. So minus of minus 280. Delta H formation of O2. O2 is standard form, therefore it will be 0. So therefore this value will be minus 1390 kilojoules or kilojoules per mole. Minus 1390, option C. So this model is very important. Next one. 6 kilojoules of heat is provided to system. 6 kilojoules of heat is provided to system. That is Q equal to plus 6. Heat absorbed by system. Heat absorbed by the system. Heat absorbed by the system can be positive. Q equal to plus 6. And work equivalent to 2 kilojoules is done on the system. Therefore, W can be plus 2. Work done on the system. Work done on the system will be positive. So, therefore, change in internal energy. So, from first law of thermodynamics, delta U equal to Q plus W. Q is 6 plus 2, that is 8 kilojoules. So, internal energy change is 8. Therefore, 8 is the answer. So, here internal energy is positive, therefore, it is increase in internal energy. Work done on the system, positive. Heat absorbed by the system, positive. Both are positive. 6 plus 2, 8. Simple. Next. So, which of the following equations are correct? Which of the following are correct? Check here. A option. U equal to H minus PV. That means internal energy equal to enthalpy minus PV, or we can write H equal to U plus PV. So which is correct? Next, B option. G equal to H minus TS. Gibbs free energy function. This is also correct. Here option C should be, here U equal to Q plus W is given, but actually It should be delta U equal to Q plus W. Therefore, it is wrong. Next, D. So, here D is not given. No need to write D. So, among A, B, C, just A, B are correct. A, B are correct means option B. C option should be delta U equal to Q plus W. Just here U equal to Q plus W is given, which is wrong. Therefore, A and B are correct. Next. Next one, adiabatic process, isothermal process, isobaric, isochoric are given. Here option A first. For A, isothermal. For isothermal, work done equal to minus nRT ln Vf by Vi. V final by V initial. Isothermal work. For B, adiabatic. For adiabatic, actually delta U equal to Q plus W. So Q is 0 for adiabatic process. Therefore, delta U equal to W. Next, C, isobaric. So isothermal means T constant. Adiabatic Q constant. That means Q is 0. Amount of heat absorbed or liberated will be 0. Isobaric delta P equal to 0. Constant pressure. Or here we can write delta T equal to 0. So isobaric constant pressure, work done equal to P delta V. Here P is constant, isobaric. Next, option D, isochoric, constant volume delta V equal to 0. If delta V equal to 0, you can write, we know delta U equal to Q plus W. In place of W, you can write P delta V. So constant volume means this will become 0, delta U equal to Q. So from these options we can select A. So A4, here it is 4, next it is 3, next it is 2 and it is 1. So option A, A4, B3, C2, D1. So different thermodynamic process. Next question. At 0 degree centigrade, enthalpy of fusion of ice is given. Molar entropy change for melting of ice is entropy change. Delta S fusion equal to delta H fusion by temperature. Here temperature must be freezing point or melting point, you can take. Melting point of ice. So here melting point, given value delta S, fusion equal to given value delta HF, that is 1365 kilocalories. Kilo means into 10 cube. Into 10 cube calories by entropy change. So temperature 273. So value will be given by 1365 divided by 273, which is equal to, here no need to take SI units, just I am taking 1367 kilocalories by 273. The value is 5 kilocalories. Therefore, 5 will be the answer. Answer 5. Simple question only. Delta H fusion by melting temperature. Melting point of ice. 0 degrees centigrade, 273 kelvins. So answer 5. So here units can be, we know delta S equal to Q by T. Q by T. So Q is joules per Kelvin or calories per Kelvin or kilocalories per Kelvin. Here kilocalories per Kelvin. Units. This is a simple question. For the reaction H2O liquid converts to H2O gas at temperature 100 degrees centigrade, that is which is boiling point of water. Choose the correct statement. Simple question only. H2O liquid changes to H2O gas at 100 degrees centigrade and 1 atmosphere pressure. So which is vaporization or boiling. Boiling point of H2. So at boiling, liquid water will be, that means heat will be absorbed by liquid water, absorption. Therefore, delta S of system increases, positive. That is, delta S of system increases. So obviously, delta S of surroundings will be negative or delta S of surroundings less than 0. So clearly option B. So at boiling point of water, heat will be absorbed by system. Liquid water absorbs heat. Therefore, system is gaining energy. Therefore, delta S of system positive greater than 0. So obviously, change in entropy of surroundings will be negative, less than 0. Next. If a chemical reaction is known to be non-spontaneous at 298 kelvins but spontaneous at 350 kelvins, then which of the following option is correct? So as the temperature increases, reaction becomes spontaneous. That means simply we can say, so here temperature increases, T1 is 298 kelvins, it changes to T2 350 kelvins, then reaction becomes spontaneous. So as the temperature increases, reaction becomes spontaneous. Then we know delta G equal to delta H minus T delta S. So if delta H is positive and delta S is again positive, reaction will be spontaneous at high temperature. Very, very important. If delta H is positive, delta S is positive, then we can write like this. Here positive value minus T into positive value. If delta G is negative, reaction will be spontaneous. Therefore, delta G becomes negative at high temperature, which is spontaneous. So option C. Clearly, as the temperature increases, spontaneity of chemical reaction increases. So this can be explained by Gibbs free energy function, delta G equal to delta H minus T delta S. If delta H is positive, delta S is positive, then delta G equal to positive minus T into positive. If delta G is negative, then the reaction will be spontaneous. That is possible only at high temperature. So option C. Next one. So this is also a simple question. Work done by an ideal gas at constant volume is constant volume. So we know work done equal to P delta V. Constant volume, at constant volume comma delta V becomes equal to 0. So therefore work done will be equal to 0. Simple question. Option C. Constant volume, no change in volume, no work done. Next. Which of the following is an extensive property? Extensive property means which depends on amount of substance. So clearly volume. Volume depends on amount. Therefore, volume extensive property. Simply B. So examples for intensive properties and extensive properties are very important. The heat required to raise the temperature of 54 grams of aluminum from 40 to 60 degrees centigrade in joules is. So molar heat capacity of aluminum is given, atomic weight 27 is given. So from this, so first I am calculating number of moles of aluminum. So given weight by gram atomic weight. Given weight 54 grams, 54 by 27, which is 2 moles, aluminum 2 moles. Next, we know amount of heat equal to N C delta T. N is number of moles, C heat capacity, next delta T rise in temperature. So from this N is 2, next heat capacity is given 24 into difference of temperature 60 minus 40. Therefore, Q equal to 2 into 24 into 20, which is 960 joules. 960 is the answer. Option C. Number of moles into heat capacity into rise of temperature. A reaction becomes spontaneous only at 500 kelvins. If delta H is 3 kilojoules, then change in entropy at 500 kelvins is. So reaction spontaneous. We know delta G equal to delta H minus T delta S. So here delta G equal to 0 at equilibrium. So therefore delta H equal T delta S. Therefore from this change in entropy equal to delta H by T. So delta H is given 3 kilojoules, kilo means 10 cube by 500. So which is 3000 by 500, 6. So answer is 6. So here joules per Kelvin. Simple question only. Entropy change delta S equal delta H by T. Next question. C plus O2 gives CO2 gas. For this delta H equal to, it should be here X kilojoules. For this process, X kilojoules per mole. Next, 2CO plus O2 gives 2CO2. For this, Y kilojoules per mole. Then, the enthalpy of formation of CO will be. Here what are given? Let C plus O2 gives CO2. For this delta H is minus X. Next 2CO plus O2 gives 2CO2. For this delta H is minus Y. These are given values. So required equation is formation of CO. Formation of CO means C plus of O2 gives CO. So for this we must calculate delta H. So CO must be on right hand side. Therefore, I am reversing this equation. So equation 1 is equation 2. So equation 1 as it is. C plus O2 gives CO2. For this delta H is minus X. Next, I am reversing expression 2. That means 2CO2 gives 2CO plus O2. For this delta H is plus Y. Next, divide equation 2 with 2. Therefore, it becomes CO2 gives CO plus half O2. We can write half O2. Here Y by 2. Next, add these two. So CO2 gets cancelled. So C plus O2 minus half O2 gives again half O2 gives CO. So for this delta H equal to Y by 2 minus X, that is equal to Y minus 2X by 2. So it is present in option B, Y minus 2X by 2. So first write equation 1 as it is. Next reverse the equation 2 and divide with 2 again. We'll get enthalpy of formation of CO as Y minus 2X by 2. Next question. Enthalpy for NaCl is given. So enthalpy means here lattice enthalpy plus 788 and hydration enthalpy is given. Enthalpy of solution will be. Enthalpy of solution equal to delta H of lattice energy plus delta H of hydration energy. So lattice energy is always positive, hydration energy always negative. Therefore, delta H of solution will be equal to delta H lattice, which is plus 788. So minus 784. Therefore, plus 4 kilojoules per mole. Plus for option B. Very, very important. Hydration energy is always negative. Next. Bond enthalpies of A2, B2, AB are in the ratio of 2:1:2. If bond enthalpy of formation of AB is minus 100, bond enthalpy of B2 you must calculate. See here, A2, B2, half A2 plus half B2 gives AB. So for this delta H is given minus 100 kilojoules per mole. Minus 100. So here bond energies. See A is the bond energy. For B2 A. A is the bond energy. Therefore A2, B2, AB are in the ratio A2 is to B2 is to AB bond energies are in the ratio 2:1:2. If bond energy is A, this becomes 2A and A again 2A. So therefore delta H of reaction equal to summation of bond energies of reactants minus summation of bond energies of products. So delta H value is given minus 100 equal to bond energies of reactants. So bond energy is A. So for A2 2A in equation by 2 is there. That means 2A by 2 plus bond energy for B2 A by 2 minus 2A. So from this we'll get value. So A plus A by 2 minus 2A. So minus 100 equal to A by 2 minus A. That implies minus 100 will be equal to minus A by 2. Minus minus gets cancelled. Therefore, A equal to 200 kilojoules per mole. So bond energy is 200, which is C. Very, very important model. In case of bond energies, delta H equal to summation of bond energies of reactants minus summation of bond energies of products we can write. Next question. The reaction in which delta H greater than delta U. So you know delta H equal to delta U plus delta Ng RT. So if delta Ng equal to 0 implies delta H equal to delta U. If delta Ng greater than 0, delta H greater than delta U. If delta Ng less than 0, delta H less than delta U. Remember this. So delta H greater than delta U means delta Ng must be greater than 0. This condition. So where delta Ng is total number of moles of gaseous products, total number of moles of gaseous reactants. So for option B, that means CaCO3 solid changes to CaO solid plus CO2 gas, delta Ng equal to 1, which is greater than 0. So therefore delta H greater than delta U. Option B. For remaining also you can check. For option A, 2 minus 2, 0. For option C, 2 minus 4, minus 2. For option D, you can check 2 plus 3, 3 minus 3, 0. All are gases. Next question. So this is about third law of thermodynamics. So correct statement regarding entropy is at absolute 0, that means third law of thermodynamics. At absolute zero, entropy of perfectly crystalline solid is zero. Perfectly crystalline means particles are arranged in a definite order. At absolute zero, entropy of perfectly crystalline substance is positive. That is incorrect. Here it is correct. It is incorrect. Third option. At absolute zero, the entropy of all crystalline substances is zero. That is incorrect. Only perfectly crystalline substance is zero. At absolute zero, that means at 0 degree centigrade, entropy of perfectly crystalline solid is zero. So only at absolute zero, only at absolute zero, entropy is zero. Entropy of perfectly crystalline solid is zero. Absolute zero means minus 273.15 degrees centigrade or 0 kelvins. Not at 0 degree centigrade, 0 kelvins. Entropy will be 0. That means limit T tends to 0 kelvins. Entropy of perfectly crystalline solid will be equal to 0. So this is third law of thermodynamics. So option A is correct. Remaining options are wrong. Next. This is a simple question only. So first I am writing given equations. S plus 3 by 2 O2 gives SO3. For this, delta H is minus 2x. Exothermic reaction, therefore delta H must be negative. Next, second equation, SO2 plus half O2 gives SO3. So for this also delta H is minus y. In equation plus means delta H will be minus. Next. So here heat of formation of SO2. S plus O2 gives SO2. So for this we need to calculate delta H. So I am writing first equation as it is. S plus 3 by 2 O2 gives SO3. So for this delta H is minus 2x. Next I am reversing equation 2. That means SO3 gives SO2 plus half O2. For this delta H becomes plus y. Next add these two. SO3 gets cancelled. So S plus 3 by 2 O2 minus 1 by 2 O2. Simply O2 gives SO2. For this delta H is y minus 2x. So for the formation of SO2, delta H is y minus 2x, which is option D. Next question. If enthalpies of formations of ethylene, CO2, H2O are given, the enthalpy change for combustion of C2H4 we need to calculate. So combustion of ethylene C2H4 gas plus O2 gives 2CO2 gas plus 2H2O liquid or gas. You can take it gas. 25 degrees centigrade. At 25 degrees centigrade room temperature, it will be in liquid form. Liquid. So by balancing, we'll get 3O2. So delta H equal to summation of delta H formations of products minus summation of delta H formations of reactants. So products 2 into delta H formation of CO2 plus 2 into delta H formation of H2O minus delta H formation of ethylene C2H4 plus delta H formation of 3 into delta H formation of O2 plus 3 into. So substitute the values. 2 into delta H formation of CO2 is given. So minus 394 plus, here it should be minus 394. Minus 394. Next. Plus 2 into minus 286 minus of here 52 plus 52 plus 0. Standard formation of O2 is 0. You get this value as minus 1412 kilojoules. 1412 kilojoules per mole. So option B. Standard enthalpy of formation of O2 can be taken as 0. Standard state. So in question, minus 394 must be there for CO2. Minus 394. Next. Next question. Heat change in calories when 40 grams of helium gas at 27 degrees undergoes isothermal and reversible expansion from initial pressure 1 atmosphere to 10 atmospheres. So here work equal to isothermal conditions. So we know delta U equal to Q plus W. So isothermal conditions, this becomes 0 at isothermal condition. Isothermal condition. So therefore Q equal to minus W, which is reversible. So minus of minus 2.303 nRT log P1 by P2. So pressure increases means compression. Therefore it should be 2.303. So N means number of moles 40 by 4 for helium. Next 2 calories R value, temperature 300 log 1 by 10. So which is equal to minus 13.82 kilocalories. Minus 13.82. So exact value minus 13.818 kilocalories, approximately minus 13.82. So option B. Next. A cyclic process ABCD shown in PV diagram for ideal gas. Which are the following diagram represents the same process? Here given AB is isobaric expansion. Next, BC is isothermal expansion. Isothermal expansion. Next, CD becomes isochoric process. DA becomes isothermal compression. So in given diagram, PV diagram, AB isobaric expansion at constant pressure, BC isothermal expansion, CD isochoric process, next DA isothermal compression. So these processes are available in option C. Check option. AB. AB is isobaric. V proportional to T means isobaric, constant pressure. That means Charles law. Next BC. Isothermal, temperature constant. CD. Isochoric, volume constant. DA. Isothermal compression. So given diagram and C diagram are matching. Therefore option C. So this is the end of the chapter. In next video I will explain one more topic. All the best and thank you.